The moon is currently tearing its own crust apart while fleeing Earth at 3.8 centimeters a year, a slow-motion suicide driven by a tidal resonance that ended before animals existed. We call it a dead rock, a silent witness. The lie is convenient because the truth is geometric horror. The moon is not drifting passively. Its rigid lithosphere is still warping in response to an orbit it hasn't occupied for hundreds of millions of years. The shape you see tonight is a fossil of a tighter, faster dance, a body permanently deformed by a gravity field it has since escaped. It is a geological phantom limb, 3.8 centimeters per year, abstract until you calculate the theft, 2 milliseconds stolen from every Earth day per century. Earth's tidal bulge, dragged ahead by our rapid spin, yanks the moon forward, boosting its orbit. But the unsettling part isn't the drift. It's that the moon's crust froze into a hydrostatic life 4 billion years ago, a fossil bulge, flattened at the poles and equator, far too extreme for its current lazy spin. The lithosphere was too cold, too strong to relax. It carries the scars of a resonance that hasn't existed since the Hadean. Simultaneously, the moon shrinks. As the deep interior cools, the radius has contracted 50 to 100 meters in the last billion years. Global compression thrusts the crust upward along lobate scarps, cliffs kilometers long cutting across fresh craters, some active within the last million years. The moon is receding outward, gaining orbital energy, while its own body collapses inward, losing volume. Pulled apart and crushed together at the same moment, the GRAIL gravity maps reveal the anatomy of this violence. The figure is triaxial, misaligned with its present axes. The maskins beneath the Maria aren't just dense lava. They are fingerprints of impacts that punctured a lithosphere already stressed by tidal despinning and thermal contraction, a palimpsest of violence. Impact, tide, cooling, each layer of stress never erased before the next arrived. Crater counts on young mare flows suggest a resurfacing event far more recent than textbooks admit, perhaps the last gasp of tidal heating as the moon punched through the Evectian resonance. 600 million years after formation, the sun's gravity wrested control of the orbit from Earth's equatorial bulge. The orbital plane flipped from equatorial to ecliptic, pumping eccentricity, flexing the crust violently. The moon's spin axis couldn't follow the flip. Today the equator tilts 5 degrees to the ecliptic. The orbit tilts 5 degrees. That misalignment is the smoking gun. Every 27 days, Earth raises a solid body tied on the moon, 10 centimeters of mantle flex. The rigid crust resists the alignment. Deep moonquakes trigger at the same tidal phase every month, detected by Apollo seismometers left half a century ago. The mantle viscosity sits at 10 to the 21st Pascal seconds. The Maxwell relaxation time exceeds the age of the solar system. The crust has no mechanism to forget the shape it froze into 4 billion years ago. Laser pulses from Apache Point hit retroreflectors left by Apollo 11, 14, 15, and the Soviet Lunokhodi's. Round-trip time measures the distance to millimeters. It confirms the 3.8 cm retreat and reveals a puzzle. Earth's oceans dissipate energy too fast. The moon should be fleeing quicker unless the deep mantle is storing angular momentum in ways we don't yet model. The endpoint is double synchronous rotation, day equals month equals orbit, at 560,000 kilometers. 50 billion years from now, the sun expands to a red giant in 5 billion. The moon will never reach tidal peace. It is fleeing a past it cannot erase, moving toward an end that will never arrive. The scar is the journey itself. Energy budget. The moon gains 7 terawatts of orbital energy from Earth's spin. It loses 10 terawatts of internal heat through conduction, driving the contraction that builds the scarps. Opposing thermodynamic arrows, one pushing out, one pulling in. The moon sits at the exact center of the tug-of-war, stretched between the gravity of its parent and the cooling of its own heart. For contrast, Phobos orbits Mars in 6 hours faster than Mars spins. The tidal bulge lags, dragging Phobos inward at 8 centimeters per year. In 30 to 50 million years, it crashes or shatters into a ring. Same physics, opposite fates, dictated only by the initial spin of the parent world. The lobate scarps are the visible stitches. LROC images show faults-cutting craters 50 million years young. Boulder falls and regolith deformation hint at movement within the last million years. Tectonically alive today, not from plates, but from the brutal physics of a cooling sphere trying to shrink inside a skin frozen by ancient tides. Every scarp is a scar the moon gave itself. This stabilizes us. The lengthening day, 22 hours in the Devonian, 400 days a year, damps Earth's obliquity, preventing chaotic climate swings that would sterilize complex life. The moon's recession is the price of our stable seasons. Total solar eclipses are a transient coincidence. In 600 million years, the moon will be too far to cover the sun. The perfect alignment we worship is a fleeting accident of the current recession rate. Consider the energy budget. The moon gains orbital energy, roughly 3.7 terawatts, from Earth's spin. Simultaneously, it loses internal heat, roughly 10 terawatts, through conduction and radiation, driving the contraction that builds the scarps. The orbital expansion requires energy input. The thermal contraction releases gravitational potential energy as the radius shrinks. These are opposing thermodynamic arrows, one pushing out, one pulling in. The moon sits at the exact center of this tug-of-war, a body stretched between the gravity of its parent and the cooling of its own heart. For a mirror image, look at Phobos. Orbiting Mars in 7.6 hours, faster than Mars rotates, Phobos raises a tidal bulge that lags behind, dragging it inward at 1.8 centimeters per year. In 30 to 50 million years, Phobos will either crash into Mars or shatter into a ring. The direction of tidal migration depends entirely on whether the moon orbits faster or slower than the planet spins. Our moon orbits slower, so it flees. Phobos orbits faster, so it falls. Same physics, opposite fates, dictated only by the initial spin of the parent world. The lobate scarps are the visible stitches of this slow tearing. High-resolution images from the Lunar Reconnaissance Orbiter show these faults cutting across craters as young as 50 million years, essentially yesterday in lunar time. Some scarps show boulder falls and regolith deformation, suggesting activity within the last million years. The moon is tectonically alive today, not from plate tectonics, but from the simple, brutal physics of a cooling sphere trying to shrink inside a skin frozen by ancient tides. Every scarp is a scar the moon gave itself. This matters for Earth. The length of day increases by 2 milliseconds per century. 400 million years ago, the day was 22 hours. The Devonian year had 400 days. This slowing stabilizes Earth's obliquity, preventing chaotic climate swings that would sterilize complex life. The moon's recession is the price of our stable seasons, and the eclipses, total solar eclipses, are a transient coincidence. In 600 million years, the moon will be too far to cover the sun. The perfect alignment we worship is a fleeting accident of the current recession rate. The moon is leaving a scar on itself at 3.8 centimeters per year. It carries a fossil bulge from an orbit it fled 4 billion years ago. It shrinks as it recedes, crushed by its own cooling heart while pulled by Earth's tidal hand. The crust remembers a resonance that ended before animals existed. The lasers confirm the drift. The scarps confirm the crush. There is no destination, only the long, slow tearing of a world that cannot forget. The silence of the cosmos is not empty, it rings with the sound of a moon tearing itself apart.